This is the 50th LeetCode challenge, and it is called PowerXN. Implement PowerXN, which calculates x raised to the power of n, i.e. xn. So if we have 2 and n of 10, 2 to the power of 10 is 1024. If we have 2.1, n of 3, that is 2.1 times 2.1 times 2.1, which is this. Then if it's x2, then to the power of negative 2, so 2 to the power of negative 2 is the same as half to the power of 2, which makes it half, which is then 0.25. Okay, let's get started. Okay, so there are some things we can do straight away. So if n equals 0, we then return 1, because everything to the power of 0 is 1. And if n is less than 0, we need to change it so x equals 1 divided by x. Yep. And then n equals n times minus 1. Okay, so got that out of the way. So let's do double output. This will equal 1. And then, so my first instinct is do a for loop over n where we times equals x to output. But I think there is a better solution to that. But I will just do that anyway. So I guess let's just run it and see if it works. And it seems like it has, but I'm not satisfied with doing this because I know there is a more efficient way. Instead of doing it for every single number in n, there would have to be a more efficient way of doing it. Okay, so I decided to look up a solution for this using a binary method, and you know, I'm going to write it out and then explain how it works. So we'll add another variable here, current, which will equal x, and instead of a for loop, we will do while n is greater than 0. So first thing we do is if n modulus 2 equals 1, what we then do is result times equals current. Output times equals current. So, but what we also do is current times equals current, and then we do n by equals 2. So to explain how this works, I'll bring up Notepad. So let's say we're doing 2 to the power of 10, so it's 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. So actually we'll also include 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's use this as an example for it. So current equals 2. We go through this. N is 10. So n equals 10, but it's an even number, so it doesn't do that. So we'll go down to here. Current is now equal to 4, because we're doing times equal, and n is now equal to 5. We then go up, n is now odd, so output equals 4, then it'll be current equals 16, and then n equals 2. So we go back up, n is even, so current, let's look at what 16 times 16 is, 256. Output is still equal 4, and n equals 1. So when we're here, n is odd, so output is now 4 times 256, which is 1024. And after all that, n will equal to 0. So then we get to here faster. So basically, in other words, you can, instead of having to do it 10 times, you can reduce it. So let's say 4, like if you add these numbers together, so 1 and 9, you know 1, 9 equals 10. That means 2 times 512 is 1024. Let's grab calculator out again. So if we do 5 plus 5, 32 times 32, that's 1024. Let's do 8 times, so 3, 128. 1024. See, 16 times 64, 1024. So, not gonna lie, don't 100% fully understand how or why this works, but let's just run it and verify that it is working. As we can see, produce the same output. So let's copy this code, put it into LeetCode here, run on the test ones. Those will work, so let's submit. Okay, interesting, we've got a wrong answer. You know what, let's put this into our as a test. Oh, then we can take a look at what's going on. So ends here, and then we'll add this one here. So actually I forgot to include an output, so put that there. Well, let's run it without that breakpoint first and see what it outputs for us. Okay, yeah, just outputs 1, which is interesting. Okay, well, let's breakpoint through it. So x is this, n is... okay. Sorry, is this not working properly? Okay. You know what, we're going to create a new variable. We're just going to make n into a double. So I assume that's what the problem is. Okay, run that. There we go. So the problem was, it was the lowest possible int number, but there is no corresponding positive int for that. So we're converting it, but then it was just going back to the lowest possible. So I've now converted it to a double, so I can actually go back to positive. Okay, doing that has now broken other things. I'm not sure how that could have affected anything. Right, yeah. Okay, well, let's take a look at this, see what's going on. Okay, well, that one's working as expected. Let's just skip until one which doesn't work. So that's 10. Okay, that goes to 4. Good. Okay. Okay, well, we're going to change it back to ints, and we're just going to do if n does not equal int 32 min value, we'll do this. Otherwise, n equals int32 max. Okay, let's run that. There we go. Okay, now that should work with all the test cases. There we go, now let's submit. Okay, still got one wrong. Okay, we've got one in here. We can do if x equals 1 or x equals -1, return x. So we'll add that as well. Submit. Okay, I guess also need to take into account, oh, maybe that should go below here, because n is negative, so it's making that one positive. Now submit. I'm not sure why that's not working. Okay, well, I guess we gotta add that into here and figure out what's going on. Okay, so go here. X is still -1. Yeah, so it returns x. Ah, I forgot to... it's meant to be -1, right? No, I was expecting 1. Oh. Okay, so because it's -1, it's going to be timesing itself. So -1, 1, -1, 1. So it's going to be using this number, and int max value is technically not correct. Okay, so we're going to have to change this. So if it's 1, then you can return. Okay, so what I'm going to do, I'm going to initialize this one up here. So if it is, we'll do current times equals current, then n equals, okay, what's the math for it? Say we have -2 and I want to make it, I want to halve that. So that times 0.5? Okay. So we'll do n times 0.5. I guess that is just divided by 2, right? -2 divided by 2, yep. So we'll do divide by 2. Then we times by -1. So we will be getting the first thing from it. Yeah, this is meant to be a 1, and we did get that, cool. So let's just copy all this, put it back into LeetCode. Let's finally add this as a test case. So run that. Didn't see those two fell in here. Oh, actually got infinity. Why does that happen? Like, isn't it just this again? So current times equal current divided by 2. Like, it will just go to there, and then we'll start doing the math for that, right? I don't understand. So, like, what if I put this one here? Would it stop being infinity? What? What I want to know is how that last one changes. Wait, okay, it's 2, -2. This one, so I don't think anything's changed here. Ah, okay. Forgot to change it over here. That must be the problem. There we go. If I left it as just being the for loop that I was doing before, I would have been done ages ago with this. Okay, now let's run it. There we go. Okay, all the test ones are done. Now we submit, and surely the very last test doesn't fail, right? There we go. Yep, so that's the 50th LeetCode challenge called POW XN. If you like this video, make sure to like and subscribe.